Okay, this is a video that is covering the lesson classifying chemical reactions. So we're going to classify them, but we're also going to be predicting products. So here's the 5 types of reactions that we cover in this class. There's more than this, obviously, but these are some pretty common, pretty simple reactions. In just the general format of them, I'm going to cover that as I talk about each one. So synthesis, you're always going to have A plus B makes AB. So the giveaway is that you have only one product that's produced. We're going to do simple synthesis, so it'll always be an element plus an element makes a compound. There are many other types of synthesis that are more complex, but that is something to be covered in another course. So here's an example. We're reacting aluminum metal with oxygen gas. So aluminum metal is just Al, and then oxygen is one of those diatomic molecules. If you remember my Brinkelhoff, that's one way to remember them. These are all the elements that are diatomic. So oxygen is never by itself, just one, it'll always find another. However, that doesn't mean you need two oxygens when it's in a compound. Then you have to look at the charge of the cation. So, in fact, here we go. So this is going to be aluminum oxide, so Al2O3. And then balancing this, I'm going to try to get 6 oxygens, so I'll put a 2 here because 2 times 3 is 6, and a 3 here. 3 times 2 is 6. And then that gives me 4 aluminums, so I'm going to put a 4 there. So decomposition is the opposite of synthesis, and we're going to do very simple ones again. So it'll always be a compound that breaks up into elements. So here's an example. Decomposition of water. Whenever you do a decomp, it requires energy. So in this time, they're using electricity. And then it's going to break into hydrogen and oxygen. So I'm remembering that those are diatomic. And then you can balance it. So when we balance this, you can see we would need 2 oxygens. So we have to put a 2 there, which gives us 4 hydrogens. So we would need a 2 here. Now I want to talk about single replacement. Single replacement, you're always going to have a single metal or a single nonmetal on the left, and then that metal replaces the metal that's in the compound, and you end up with a new single metal. If it's nonmetal, it replaces the nonmetal, and then you have a new compound and a new nonmetal that's all by itself. So when you're doing single replacement reactions, we use this activity series. This is on your periodic table. So a metal like magnesium would be able to replace any metal underneath here. But if it was magnesium plus sodium chloride, that reaction would not happen because sodium is more reactive. So let's do a few examples. So here we are. We're going to do iron. You normally don't write this, but the only reason we do is just so you know how to write the formula of the compound. So we're really comparing iron and copper. And then we find them on this activity series. Here's iron. And where's copper? Here's copper. So that reaction will happen. So then you want to, this is what's really happening. The copper is getting pushed out, and then the iron is going to go with the sulfate. So when I put those together, I do need to balance charge and write the formula so that it's neutral, like that. And then balancing it, you can see that we're going to need 3 sulfates. That gives me 3 coppers and then 2 irons. So the next one is a nonmetal. So bromine is a nonmetal. So now I'm going to use just this little area over here. So bromine and chlorine. That's not going to happen. Bromine can only replace iodine. So this one you would just write no reaction. Next one, magnesium and aluminum. So that one will happen because this one's higher. The magnesium has got to be more reactive than the one it's trying to replace. So magnesium will go in and then kick out that aluminum. And then you need to look at charges and write the formula. And then, you should balance it. 2 and a 3. Let me show you one more, like one with a nonmetal that does happen. So let's say you have fluorine, because fluorine is the most reactive. And then let's say you're going to react that with lithium chloride. So this will happen. And your fluorine is the nonmetal, so it's going to replace the nonmetal. So I'm going to end up, pushing out the chlorine and remembering it's diatomic. And then the lithium and the fluoride are going to go together, but you have to look up charge. So it'll be LiF. And then you can balance it at the end. Next, I want to cover double replacements. So double replacement reaction, I think of it as the metal or the cation switch spots. And then when you come over here and write the formulas, you do have to balance the charges to write the, neutral formula. And when you have a double replacement, a lot of times you will have a precipitate that forms. You guys saw this in the lab that we did. Your precipitate was, you had 2 of them. One of them was that really pretty kind of aqua blue, and the other one was the black. Those were precipitates. So double replacements produce a precipitate or a gas or water, always. So here's an example. Predict the products with silver nitrate and potassium chromate. So I would have to look up on my pink sheet, silver is plus, nitrate is minus, and then potassium is plus, chromate is 2 minus. And then I'm going to write those formulas. So if you want to pause the video and write those formulas. So my formula is just going to be AgNO3 plus K2CrO4. Then when I get over here, I'm switching. So the silver is going to go where the potassium is. Potassium goes where the silver is. But so my potassium now is going to go with the nitrate. So notice I didn't bring the 2 with. That 2 is there because of the balancing the charges. The only time I bring subscripts with is if it's part of the polyatomic ion, like the 3. The silver is going to go with the chromate. So then our formula is going to be KNO3 plus Ag2CrO4. And then you can balance it. We're going to need 2 silvers. We're going to need 2 nitrates and 2 potassiums. So that is it. Combustion reactions. In a combustion reaction, you're going to have a hydrocarbon. Sometimes it has an O in there. And then the three things that are always constant, you're always going to have oxygen. It has to react with oxygen. And then you'll always form carbon dioxide and water. So this, we'll do one example. So this is a hydrocarbon. So we're going to react it with oxygen, and it's going to form carbon dioxide and water. So remember how when we balance these, I recommend that you go in this order. So we would have 5 carbons on both sides, 10 hydrogens on both sides, and then I'm ready to count. So I have 10 oxygens and 5 oxygens for a total of 15. And so it's an odd number. So this is the time where you can write a fraction only in front of diatomic molecules. And remember, if you don't like that, you could put 7.5, but you wouldn't want to leave that. What you would do then is multiply the whole reaction by 2. So this is a 1, it changes to a 2. 7.5 times 2 is 15. And then these will both change to 10. And that is correct also.